Alright, so let's get started. I want to talk about the 45, 45, 90 triangle. Alright, so usually we find out that most triangles goes angle and then side length is similar. You go angle and side length and side length. So we find that the 90-degree side length, which is this side, is usually always bigger than these side lengths. As we're in this one, in the 30, 60, 90 triangle, we have the 90, which is usually c squared. It's always the biggest one, the hypotenuse. We got the 60, which is usually the second biggest. And then we have the 30-degree angle, which is usually the smallest, and it's usually a squared plus b squared equals c squared. So this would be your formula. And for the 45, 45, 90 triangle, it'd be still c squared, and then the 45s are the exact same height, which could be a squared plus b squared, but I mean they're the exact same, so it's a squared plus a squared. Now for the octahedron, tetrahedron, and the icosahedron, they are all triangles, and what we want to talk about is how that they are all three-dimensional and they have the congruent same shape. So they're all triangles, and they're all the same triangle, just made into a 3D shape. And they all have congruent vertices. So if you look at the icosahedron, you can see, if I clear this off, I don't know if I can, I was drawing on it earlier, that this triangle right here and this triangle is the exact same triangle, just flipped upside down, and it's also the same as this triangle and this triangle. And the tetrahedron and the octahedron are the exact same like triangles. It's just there's two tetrahedrons connected to each other to make the octahedron, and that's 8 triangles together. Compared to the tetrahedron, which is just 4 triangles. It's a triangular pyramid. And then the cube and the dodecahedron are different because they're not triangles. The cube is a square. It's just a bunch of squares made together make a cube. And then the dodecahedron is a bunch of pentagons that are the exact same as well. They're all the exact same shape with congruent faces and congruent corners. And they made a 3-dimensional shape, just like the cube and all the other tetrahedron, octahedron, and icosahedron. Now, the last one we're going to talk about is question 2, and it's explain how the Euler's formula works for prisms and pyramids. The Euler's formula is vertices plus faces minus edges equals 2. And so we have some prisms right here, and we'll show you how that works. We'll do the triangular prism first, and we'll look at the faces. We have 5 plus 6 minus 9 equals 2. We have 11 minus 9, and that equals 2. So it does work for that. Now let's try a pyramid. Let's do a pentagonal. And here's our pentagonal. We have this one's different, but they're pretty much the same. So it'd be 6 vertices plus 6 faces minus edges would equal 2. Oh, I forgot the edges, which is 10. So 6 plus 6 is 12 minus 10 equals 2. And that is true as well. Thank you.